Hello and welcome to today's webinar, PFAS in Massachusetts Drinking Water, an update on research and regulation. My name is Michelle Dixon and I am the Program and Development Director for Massachusetts Breast Cancer Coalition, and I'd like to thank you all for joining us today. I am pleased to welcome back today's speaker, Dr. Laurel Shader. Dr. Shader is a research scientist at Silent Spring Institute, where she leads the Institute's water quality research on PFAS and other contaminants of emerging concern. She studies PFAS chemicals in drinking water, consumer products, food, and in food, drinking water contamination from septic systems, and environmental justice disparities in drinking water quality. She is the lead investigator of PFS Reach, Research, Education, and Action for Community Health, a study evaluating PFAS toxicity in children and addressing the needs of communities affected by PFAS water contamination. She is part of the University of Rhode Island's DEP Superfund research program and co-leads community engagement activities on Cape Cod, including a study of private wells that you'll hear about today. She is also the lead investigator on a new study announced last month, funded by the Centers for Disease Control and Protection on PFAS health effects in 2 communities in eastern Massachusetts. Before joining Silent Spring, she was a research associate at the Harvard T.H. Chan School of Public Health. Dr. Shader earned her master's and PhD in environmental engineering at the University of California, Berkeley, and a bachelor's degree in environmental engineering science from MIT. Dr. Shader, welcome back.
Thank you, Michelle. Thank you to the Massachusetts Breast Cancer Coalition for inviting me to take part in today's webinar, and thanks to all of you for tuning in. Today, I will be presenting an update on PFAS in Massachusetts drinking water. I'll provide an introduction to PFAS for those of you who may be tuning in for the first time, and tell you about some recent research that we have underway, and provide an update on regulations here in Massachusetts. So I'll start out by talking about what are PFAS chemicals. I'll talk about what we know about PFAS in Massachusetts drinking water, tell you about several health and exposure studies that are underway here in Massachusetts. I'll share some preliminary findings from a study of private well water quality on Cape Cod as part of the DEP Superfund research program, and end with some tips for things that you can do. So PFAS are a class of chemicals that are in the news every day. They've shown up in drinking water supplies across Massachusetts and across the country, and state governments, including in Massachusetts, are setting aside money for additional testing and treatment to address PFAS in water. I'll talk today mostly about PFAS in drinking water, but as we'll talk about, PFAS are common in many consumer products. In addition to our studies of water quality, we've also linked PFAS exposures with certain consumer products like Oral-B Glide dental floss and stain-resistant carpets. And most recently, we found that people who eat more microwave popcorn and eat more food out of their home tend to have higher PFAS exposures. So PFAS may not be a household name, but products containing PFAS chemicals are very familiar to all of us. Think of Gore-Tex, Teflon, Stainmaster, and Scotchgard. They're used in many types of stain-resistant carpets and upholstery, waterproof apparel like rain jackets, certain types of waxes for waxing floors or for skis, nonstick cookware, grease-proof food packaging like fast food wrappers, dental floss like Oral-B Glide, and certain types of paints. And these have been used in consumer products since the 1950s. So what does PFAS stand for? Well, it's got a long chemical name, per and polyfluoroalkyl substances. We used to call them PFCs, which was a little bit easier to say, but now we call them PFAS, which is a term that encompasses this whole chemical family. And this family of chemicals has some characteristics that makes them pretty unique. One is their extreme persistence. Some people call them forever chemicals, and others have suggested that they may persist on geological timescales. It's a complex family of chemicals. It's been estimated that there are over 4,700 PFAS compounds in use. And they're a very versatile class of chemicals, and they're widely used, not just in the consumer products I've mentioned, but they have many industrial applications as well. So here are the chemical structures for two of the most common PFAS chemicals, PFAS, PFOS, and PFOA, or PFOA, sometimes called C8. Both of these are called long-chain PFAS chemicals, and that's because they have a long, fully fluorinated carbon backbone. These are extremely persistent, just like other PFAS chemicals. They're actually no longer manufactured in the United States, although they continue to be present in the environment. In their place, manufacturers have switched to other PFAS chemicals. Some of them are shorter chain versions of PFAS and PFOA, and others have different variations in their chemical structures. So how do we get exposed to PFAS? There are several different pathways from the manufacture of these chemicals to us. Some of our exposure can come from consumer products, so food packaging or inhaling PFAS that are associated with fibers, say in stain-resistant carpets or furniture. They can also get to us through our food because PFAS are common in the environment. The plants and animals that we eat can absorb them from their surroundings. And then for some Americans, water is also an important source of exposure. It's typically thought that for the general population that food is the largest source of exposure, but scientists are still learning more about the relative contributions of all of these different exposure pathways. So how do PFAS get into drinking water? One of the most common sources of contamination is a class of firefighting foams called AFFF, or Class B foams. These are used for fighting fuel fires. So they are typically found near military bases, airports, and other fire training areas. High levels of contamination have also been found near chemical manufacturing facilities. For instance, 3M and DuPont plants, where these chemicals are produced. They've also been found near industrial facilities that use Teflon or other PFAS-containing products. So, for instance, here in New England, in Merrimack, New Hampshire, and in North Bennington, Vermont, there are St. Gobain facilities that have contaminated the local area because of their use of Teflon in their manufacturing processes. Because these chemicals are so common in our everyday lives, the wastewater, municipal wastewater also picks up traces of these PFAS chemicals. So places where wastewater gets discharged into the environment, septic systems or discharges from wastewater treatment plant can be a source. And we're also learning more about biosolids, so the residual from wastewater treatment plants. Locations where biosolids have been spread on the land can also end up contaminated with PFAS because the PFAS can be found in the biosolids. Landfills are also a source of PFAS contamination because the products that we use that have PFAS end up in the landfills, and because the chemicals don't break down, they can end up either in the leachate that enters groundwater if it's a landfill that isn't lined. If it is lined, then the leachate tends to go to a wastewater treatment plant, and again, because the chemicals don't break down, they either end up in the wastewater effluent or in the biosolids. So across the country, there are an increasing number of sites where there's been PFAS contamination found. The most recent estimate is 610 contaminated sites in 43 U.S. states. This is a map that was put together by the Environmental Working Group and our colleagues at Northeastern University at the Social Science Environmental Health Research Institute. And this shows locations where PFAS have been found at military bases or other known sites, and also where PFAS have been found in drinking water. A conservative estimate is that 19 million Americans have PFAS in their drinking water, and the Environmental Working Group puts that number at more like 110 million Americans. So why is this exposure concerning? Well, we know that nearly all Americans have detectable levels of PFAS in our body. For PFAS and PFOA, the long-chain chemicals, these have very long half-lives in our body. These are chemicals that are very difficult for our bodies to excrete. So once we've been exposed, they circulate in our blood for many years. The newer replacement chemicals still can reside in our body, not for years, but for months, and that's still considered a moderate half-life because they're not cleared very rapidly from our bodies. A number of studies have looked at the harmful health effects of PFAS exposure. Some of these are toxicological studies that are conducted in laboratory animals, and others are epidemiological studies, so studies in populations of people that have been exposed. Some of these are communities with high exposures from drinking water or from food, and others are conducted in the general population because, again, all of us are exposed to PFAS chemicals. Most of what we know about PFAS comes from or focuses on PFAS and PFOA, and we have limited information about other PFAS chemicals. Some of the health effects that have been linked to PFAS exposure include immunotoxicity, particularly decreased vaccine response in children, elevated cholesterol, thyroid disease, certain types of cancer like liver, testicular, and pancreatic cancer, and laboratory studies have shown alterations in mammary gland development, and this is of concern to us because we think that may increase susceptibility to breast cancer. So moving on to the second section, PFAS in Massachusetts drinking water. So back in 2013 to 2015, the EPA required large public water supplies across the country to test for PFAS chemicals. PFAS aren't regulated in drinking water, and typically water suppliers don't test for these chemicals. From that testing, there were 5 water supplies in Massachusetts that were found to have the highest, or found to have detectable levels of PFAS. I would note that the testing that was conducted didn't use a very sensitive method. So it's likely that there are other water systems that contain PFAS that weren't reported. And in fact, one of the analytical laboratories that did this testing later discussed that more than 40 water supplies in Massachusetts have detectable PFAS levels. Since that testing occurred from 2013 to 2015, there have been additional discoveries of PFAS, both in other public water supplies as well as private wells too. Silent Spring Institute has been studying PFAS in drinking water for about 10 years now. We first found PFAS back in 2010 as part of a broader study of unregulated emerging contaminants in Cape Cod drinking water. At that time, we were just testing for PFAS and PFOA, and we did find them in a number of the public wells that we tested. The highest levels that we found were in the Hyannis water system, and this was the first time that anyone had looked for PFAS in drinking water. We've since learned that the Hyannis water wells are impacted by a county fire training academy and potentially in the airport as well. And the Hyannis water system has gone to great lengths to introduce new water treatment and to bring the levels of PFAS down. And they're now meeting a Massachusetts guideline, which is stricter than the EPA guideline, which I'll talk about in a minute. In the following year, in 2011, we did a follow-up study of private wells on Cape Cod as well. And we found a combination of both longer chain, older chemicals like PFAS, as well as some of the shorter chain, newer alternatives in a number of the wells that we studied. I would note that this was a smaller study, just of 20 private wells, and the study that I'll talk about later today is a much larger study and will provide new insights. So currently there are no federal enforceable drinking water standards called MCLs for any PFAS chemicals. So under the Safe Drinking Water Act, there's no requirement for public water supplies across the country to test or to treat for PFAS chemicals. The EPA and some states, including Massachusetts, have developed non-enforceable health advisories for PFAS, PFOA, and several other PFAS chemicals. A couple of states are also moving towards having enforceable standards, which would require ongoing testing and monitoring. This is a study that Silent Spring Institute co-authored early this year, and this looked at the varying landscape of PFAS drinking water guidelines in states across the country and explored why different states have come to different conclusions about what the regulatory levels for PFAS in drinking water should be. We found that over time, as new studies found health effects at lower and lower levels, that contributed to the downward movement in PFAS drinking water levels over time. We also found that there are different assumptions and interpretations that go into the process of making drinking water guidelines. And some of these have to do with different interpretations of the science and how scientists and regulators put together the available studies. There are also different assumptions that go into the process of translating scientific findings into a single value, a single level for drinking water. And there are also different assumptions about the most sensitive subpopulations, for instance, infants and pregnant women. Since our paper came out earlier this year, there have been additional states who've developed or proposed drinking water guidelines. Again, you can see here in 2016, that's when EPA issued its lifetime health advisory of 70 parts per trillion for the total amount of PFAS and PFOA. And the most recent guidelines that have been developed over the past year are much lower than that and typically in the range of 10 to 20 parts per trillion, nanograms per liter. So what's happening here in Massachusetts? So last year, in June of 2018, the Massachusetts Department of Environmental Protection, or DEP, issued a public health guideline called an ORSG, the Office of Research and Standards goal. And they set that level at 70 parts per trillion, not just for PFAS and PFOA, as the EPA did, but for the sum of 5 common PFAS chemicals. This is a guideline, and this has led to additional water systems doing testing and taking steps to meet this guideline. But I'll note that it's not enforceable in the same way that an MCL would be. And then last fall, there was a petition from the Conservation Law Foundation and Toxics Action Center. They submitted petitions to all 6 New England states asking for additional consideration of enforceable standards and standards that would better address PFAS as a whole class of chemicals rather than one chemical at a time. In response to that petition, Mass DEP had a public hearing in January. You can see a picture of myself and Cheryl Osimo, the executive director of MBCC, providing comments on the draft proposal. And since that time, DEP has been moving through a process to establish both drinking water standards and guidelines for the remediation of contaminated sites. So starting in April, they launched that process. And in June, they issued a draft GW, which is Groundwater Standard, and this is for groundwater that's currently used or could be used in the foreseeable future for drinking water. And it's quite a bit stricter than the ORSG that they issued in 2018. Instead of 70 parts per trillion, they've lowered the level to 20 parts per trillion, and they've included an additional PFAS chemical. What's coming on the horizon? Mass DEP is working to finalize this groundwater standard, and then we'll be moving forward with the process of developing a drinking water standard, or MCL, for public water supplies. I wanted to let you know about several health and exposure studies that are currently underway here in Massachusetts. One of them is called PFS Reach, Research, Education, and Action for Community Health. This is funded by the Research to Action program at the National Institute of Environmental Health Sciences. One of the goals for PFAS Reach is to study PFAS exposures and potential immune system toxicity in 120 preschool-age children. We have 2 communities in our study. One is Hyannis on Cape Cod, and the other is at the Pease Trade Port in Portsmouth, New Hampshire, which is another area that has had firefighting from contamination of the water supplies in the past. For PFAS Reach, we've just gotten our approvals and recruitment is officially underway. So we're looking for parents of young children who live in Hyannis to sign up for our study. And I have a website at the end that you can look at to get information about the study. Silent Spring Institute is the lead institution for PFAS Reach. We're also including researchers from Northeastern University, including Phil Brown, who provided an MBCC webinar just last week, and Michigan State University. For community partners, we're proud to be partnering with the Massachusetts Breast Cancer Coalition, as well as Testing for Peas and Toxics Action Center. One of the other components of PFAS Reach is the PFS Exchange. This is designed to be an online resource center for people in PFAS-affected communities and for other audiences of people who'd like to learn more about PFAS. Part of the PFAS Exchange includes a community connection page where users can click on a certain state and learn about contamination sites, they can learn about health studies, and they can learn about community groups that are addressing PFAS issues. We have fact sheets, and we are also developing a data interpretation tool for people who've gotten their water or their blood tested and want more help interpreting what those results mean. The second study it's funded by the ATSDR. This is Agency for Toxic Substances and Disease Registry. That's part of the Centers for Disease Control and Prevention. And just last month, we found out that our proposal was selected as one of 7 projects funded across the U.S. So Silent Spring Institute is the lead organization, and we have a great team of partners for this project as well. We're partnering with the Harvard Chan School of Public Health and the Eastern Research Group. We're also proud to be working with Massachusetts Breast Cancer Coalition, who's our community partner in Hyannis, which is one of our 2 study sites. And we're working with the People of Air Concerned About the Environment, or PACE, as our community partner in AIR. AIR is another community where the public water supply in the past had much higher levels of PFAS chemicals because of contamination from firefighting foams nearby. And again, the water suppliers in both Hyannis and AIR have taken steps to bring the levels of PFAS much lower in the water supply. But because these chemicals are so persistent in our bodies, we're concerned about the potential long-term effects from past exposures. The ATSDR Multisite Health Study will involve 1,000 adults and 300 children combined in AIR and in Hyannis. And the study will ask participants to provide blood and urine samples for children, to complete neurobehavioral testing, and to fill out questionnaires as well and provide medical records. And the goal of the study is to look for associations between PFAS exposures and a range of health effects, including levels of cholesterol and other lipids, thyroid hormones, liver and kidney function, and many others. So we just found out about this study, again, because it's a coordinated study across 7 sites. There will be considerable effort to coordinate among the different projects. Our study, in addition to the core elements that each of the 7 projects will conduct, will also provide new information, not just about PFAS and PFOA and a range of other commonly measured chemicals, but whether there are other unidentified PFAS chemicals as well. And we anticipate recruitment for this study starting next year. I wanted to mention one other study that ATSDR has underway. Silent Spring Institute is not part of this study, but for those of you in Western Massachusetts, I wanted to make you aware of this other ATSDR study. So in addition to the multi-site health study that I just mentioned, ATSDR is also conducting a series of exposure assessments. Their goal is to characterize PFAS exposures in communities with PFAS water contamination from military sites. Westfield is one of 10 communities that is part of this ATSDR exposure assessment. And ATSDR was out in Westfield over I believe about a month ago, collecting blood samples, urine samples, and asking participants to fill out questionnaires as well. And they had an overwhelming response from the community. They had more people than they anticipated, with over 450 residents providing blood and urine samples and completing these questionnaires. One of our other research initiatives here at Silent Spring Institute is the STEEP Superfund research program. And I'll tell you now about initial findings from a study that we've conducted of private well water quality on the Cape. So STEEP stands for Sources, Transport, Exposure, and Effects of PFAS. STEEP is led by the University of Rhode Island, and it also includes researchers from the Harvard Chan School of Public Health and Silent Spring Institute. And this study is funded by the National Institute of Environmental Health Sciences. They have a Superfund research program designed to provide new information about environmental movement, remediation, and health effects of chemicals that are commonly found at Superfund sites. Part of Silent Spring's contributions to the STEEP Center focus on community engagement activities on Cape Cod. I'm one of the 2 project leaders for the Community Engagement Corps on Cape Cod, as well as Allison McCann, who's at the University of Rhode Island. So the goal for our community engagement activities include hosting an annual Science Day on Cape Cod. Just this month, on October 2nd, we held a series of events at the Barnstable Town Hall, including a session for high school students that attracted 80 students and teachers from 5 different high schools on the Cape, as well as providing presentations by STEEP researchers and providing residents the opportunity to ask questions and to meet with STEEP researchers. We've been taking part in community events. Here are some pictures of community events we've taken part in, including the Orleans Celebrate Our Waters event in September. We aim to promote exposure reduction and intervention strategies, for instance, promoting well water testing among private well owners. And we also have a goal to study PFAS in Cape Cod private wells. So as part of our community engagement core, we're working with several community partners. One of our partners is the Massachusetts Breast Cancer Coalition, including Cheryl Osimo, who is a resident of Cape Cod, and she's also our Cape Cod Outreach Coordinator here at Silent Spring. We're also working with the Sierra Club Cape Cod group, and we have a STEEP Cape Cod Advisory Committee, which includes county and town officials, as well as other residents on Cape Cod. And here on the bottom here, you can see the STEEP Project Director, Reiner Lohman from the University of Rhode Island, speaking to the high school students on our Science Day this year. So why is STEEP focused on Cape Cod? Well, for one reason, the groundwater on Cape Cod is vulnerable to contamination. We think of it, call it a sole source aquifer. There are different sections of the aquifer, but everyone on the Cape relies on groundwater for their drinking water. There's been contamination of public and private wells on Cape Cod because of the use of AFFF firefighting foams, in particular at the Barnstable County Fire Training Area and Joint Base Cape Cod, as well as other locations. Silent Spring Institute has been working on Cape Cod for 25 years since we got going. And so we have a lot of community engaged research experience on Cape Cod. And as I mentioned earlier, we were the first to find PFAS in drinking water on the Cape. And we know that there are a lot of questions and concerns among residents on Cape Cod about water quality and health. So I'm going to talk now more specifically about our private wells study. Our goal is to test 250 private wells for a range of PFAS chemicals. We are reporting results back to individuals about what we find in their individual well water sample. We're evaluating potential sources of PFAS beyond just firefighting foams that we're already aware of. For instance, we want to know more about the potential contributions of septic systems to PFAS in groundwater. We aim to promote private well testing, not just for PFAS, but more broadly to raise awareness among private well owners about the need to monitor water quality over time and as necessary to install treatment. And we aim to report back not just to our participants, but also to residents on the Cape and decision makers. There are some collaborators in our study as well as part of the STEEP project. At Harvard University, Elsie Sunderland and her lab have conducted the actual analyses for PFAS as well as for heavy metals, as well as research scientists and others here at Silent Spring and University of Rhode Island. And we've had a number of people help out with our field sampling. We do collect all the water samples ourselves because PFAS are so common in consumer products. We have certain protocols that we have to follow to collect our samples to make sure any PFAS we find in the water is coming from the water and not artificially added into the sample during the sample collection process. So in 2018, we collected water samples from 101 private wells all throughout Cape Cod, and this is showing the numbers of participants that we had, people that signed up on the bottom, and the number of wells that we actually got to sampling. In the towns where we didn't collect any samples are towns where there are really very few private wells. This is another map in orange that shows where we actually collected our water samples, and the blue dots show areas with known private wells. So in general, we did a pretty good job of collecting samples from many of the areas that are served by private wells on the Cape. So I'll share some preliminary findings, again, based on the first 101 wells for which we have results. We found PFAS chemicals detected in nearly half of the wells we sampled, and 28% of wells had 2 or more PFAS chemicals detected. The individual chemicals that we found included both legacy chemicals like PFAS and PFOA that are no longer manufactured in the US, and newer alternative PFAS chemicals. Some of the chemicals we found were among the 5 that are in the current Mass DEP guidelines. Other chemicals that we found don't have any drinking water guidelines here or in any other state in the U.S. None of the wells that we tested exceeded the current Mass DEP or EPA guidelines. Again, DEP has proposed a guideline of 20 parts per trillion for the total amount of 6 PFAS chemicals. And if adopted, we found that 3% of the wells we tested would fall above that new guideline. Here's a little bit more information specifically about the most commonly found chemicals. There were 3 chemicals that were found most commonly here. So PFOA and PFAS, again, they're the ones that are most found frequently in other studies of water as well. And PFPEA, which is a shorter chain version of PFOA, so it's a replacement chemical. And PFPEA was the most frequently found. But most of these chemicals were found in a small percentage of wells. In terms of the maximum level that we found in parts per trillion or nanograms per liter, the highest level was typically around 10 parts per trillion, and there were several chemicals that were found in the tens of parts per trillion. And the final column just tells you the lowest level that we were able to report on for each of these chemicals. One of the questions that we have is whether wells with higher levels of nitrate have higher PFAS levels. And we're asking that question because we know that nitrate is a marker of septic system impact, and we're curious whether wells that show more septic system impact are likely to have more PFAS chemicals. What I've done here is to separate the wells that we tested into 3 groups. So less than 0.5 milligrams per liter, so that's pretty consistent with background levels or just slightly elevated above background levels of nitrate. Moderate nitrate, so 0.5 to 5 milligrams per liter, and then high nitrate, which is over 5 milligrams per liter. I would note that the standard for nitrate in drinking water is 10 milligrams per liter, and that's based on health studies specifically for nitrate. We did have 2 wells that were over that guideline, but in this case, we're thinking about nitrate as a surrogate or a marker for septic system impact. And what this graph is showing is that on average, wells with higher levels of nitrate also tended to have higher total PFAS concentrations. We were also curious whether there were any differences by region or by town on the Cape. For some towns, we only had a couple of wells that we tested, so rather than comparing a limited number of samples in certain towns, what we've done here is to group the wells by region, and we did see somewhat higher detection frequencies in wells in the Upper Cape and the Mid Cape compared to the Lower and Outer Cape, and that may be due to higher population densities. So each of the participants in our study received an individualized online report with their own findings, as well as a summary of overall results. And this is developed with a tool called DERBY. This is the Digital Exposure Report Back Interface. And this has been developed by researchers at Silent Spring over the course of many years, based on our extensive work to understand how people best understand information about chemicals that may be in their bodies or in their water or in their household. We've learned over the years that different people like information in different ways, and so our report provides a combination of high-level overall findings as well as very detailed chemical-specific information. So for participants who took part in the study, they would be able to log in, and this is the page showing results for PFAS chemicals. So the page shows information at the top about where chemicals come from, how they're regulated, and then when people scroll down for each of the chemicals that we found in the study, they can see a graph that shows their level and how they compare to other wells in the study. We've learned that people really find it helpful to learn how they stack up to other people that take part in the study, even when there's no guideline. And then we also show any relevant health guidelines, for instance, the DEP guideline for the sum of 5 PFAS. The report also provides information about what you can do, for instance, taking steps to treat their water, exposure reduction tips more broadly for PFAS chemicals and suggestions for ways that people can take action in their communities. So overall, from our private well study, we found that PFAS chemicals were found in nearly half of the wells that we tested. We found that higher nitrate wells had higher PFAS levels, suggesting that septic systems are one source of PFAS. Of course, nitrate might also just be a surrogate for more human activity, so it's possible there are other sources as well. The presence of PFAS chemicals that have been phased out reflects their extreme persistence in the environment. And no wells exceeded the current state or federal guidelines, but Mass DEP and other states are developing stricter guidelines and standards. So the next steps for our study include collecting water samples from additional wells. We anticipate going back out in the spring to do our next round of sampling. We'll be evaluating associations between PFAS concentrations and the proximity of wells to a wide range of potential sources. So for instance, we'll use land use density, particularly residential density, to predict septic system impacts. We'll look at locations of wastewater discharges into the ground, landfills, fire stations, and fire trading areas, including Joint Base Cape Cod, airports, and then other types of commercial activities like laundromats, car washes, and car dealerships where PFAS-containing products may be used. And the goal for this is to identify what are other potential sources of PFAS getting into groundwater, and are wells that are close to one of these sources more likely to have PFAS showing up in their water. We're still looking for volunteers, so if you live on Cape Cod or you have own a home on the Cape that has a private well, it's not too late to sign up for the study. We'll ask you to complete an online consent form and a questionnaire about your well. Members of our STEEP research team would come to your home to collect the water samples, and you'd receive a detailed report with your results. So I'll conclude here by talking about what steps you can take. So at an individual level, we can all take steps to reduce our PFAS exposure. For instance, we can avoid stain-resistant carpets and upholstery. We can avoid products that have prefixes like perfluor or polyfluor in the label, or PTFE, which is a fancy way of saying Teflon. Can select cast iron or enamel cookware. Eat more fresh foods to avoid contact between food and PFAS-containing packaging. Minimize your contact and use of fluorinated ski waxes. And if you're concerned about PFAS in your drinking water, you can install filtration in your home to filter out PFAS chemicals. And as a guiding principle, I like to think of asking myself, is this a product that I really need to have PFAS? And there's been a new paper earlier this year by other researchers talking about essentiality and how can we classify uses of PFAS that are absolutely essential and which ones are non-essential. For more tips about household exposure reduction, I recommend our Detox Me smartphone app, which is available for both iPhones and Android. So how do I know if there's PFAS in my water? Well, if you're on town or city water, you can call your local water district or find the Consumer Confidence Reports. These are the annual water quality reports, and they should be available online or from your water district. If your water supply took part in the UCMR testing, there is information about that on the DEP website, and there are more recent test results that are online through the EEA portal. If you're on a private well, you can talk to your town's health agent to see if there's been any testing done in your community or any information about PFAS groundwater contamination. If you live on the Cape, you can get your water tested through the STEEP program. And I know that the Barnstable County Laboratory is also working on developing its capacity to offer PFAS water testing to residents. If PFAS are found in your water, there are two types of treatment that can remove PFAS from drinking water. One type of treatment is activated carbon. This can either be a solid carbon block filter or a filter pitcher that contains granular activated carbon. Activated carbon filters are very effective for PFAS, PFOA, and other long-chain PFAS. Shorter chain PFAS, which are alternatives, are not as well removed over the whole lifetime of a carbon filter. A second option is reverse osmosis. This is effective for both long-chain and short-chain PFAS chemicals. The downside of reverse osmosis is that it's more expensive and it generates a larger stream of wastewater because for every gallon of treated water, these systems produce several gallons of wastewater, and that can affect the performance of septic systems. If you are buying a filter, it's important to look for filters that have been certified to remove PFAS. So far, the only types of certification apply just to PFAS and PFOA to ensure that the water would meet the EPA lifetime health advisory, the 70 parts per trillion. So there's no independent certification for meeting the Massachusetts guidelines, but it's a good place to start. And here's information about the National Sanitation Foundation and ANSI standards to look for when you're buying a filter. If you'd like more information and tips for treating water or for reducing your family's exposure, one resource is the STEEP website, which has a range of resources with tips for reducing exposure and learning more about PFAS health effects. Our PFS Exchange website also has fact sheets, community resources, and we'll soon have a data interpretation tool as well. So with that, I'd like to thank you for your attention, and this last slide here provides the websites for all the resources that I talked about today here at Silent Spring, at STEEP, and the PFAS Exchange. So thank you.
Thank you. Dr. Shader, we have a couple of questions that have come in. Could you speak briefly about if there are standards for bottled water?
That's a great question. So, bottled water, instead of falling under the Environmental Protection Agency, falls under the FDA. And I'm not aware of any standards for bottled water, just as there aren't any standards for tap water either. People often assume that bottled water comes from a pristine location, but often bottled water can just be tap water that may or may not be treated and then put in bottles. There was a bottled water supplier in Haverhill that was found to have PFAS levels that exceeded the EPA lifetime health advisory. So just because it's in a bottle doesn't guarantee that it has lower PFAS levels. If you want more information about PFAS levels in bottled water, the DEP website does provide information about bottled water that has been tested for PFAS. I would note that this information is voluntarily provided by the water suppliers, so it's not a complete testing. And there really hasn't been very much testing of PFAS in bottled water overall. So for people who are concerned about contaminants in their drinking water, we recommend testing your water and putting in treatment rather than bottled water, unless there are very high levels of contaminants of concern.
Okay. And are there effective techniques for removing PFAS chemicals from soil sources on land or contaminated sediments in freshwater kettle hole ponds?
So PFAS are very difficult to remediate. Again, they don't break down in the way that other pollutants can break down. So the remediation techniques that we have available are pretty limited. One option is to remove the contaminated soil or sediment off-site. That doesn't remediate the problem and remove or degrade the chemicals, but can be used to clean up a contaminated site. The other option that's used for soils, not so much for sediments, is called pump and treat. So the idea is that groundwater is pumped out of the ground, put through an activated carbon filter, and then put back into the ground. And that's often used in conjunction with removing the soils that have the highest PFAS levels. Scientists are also looking at other remediation options, but there really aren't any good options. There are strong chemical oxidizers that can be used, but these aren't effective for all PFAS and create other unwanted byproducts. The other way to break down PFAS is at very high temperatures, so they can be incinerated, there are concerns about the performance of incinerators, what happens if incinerators aren't operating at a high enough temperature, and the potential for releases into the communities near incinerators. But incinerators are used, for instance, in the regeneration of the activated carbon treatment that's used by public water supplies to treat drinking water.
And you had noted early in your presentation that PFAS chemicals have been in products since the 50s. When was the alarm bell set off in terms of when did this become a focus of research and concern across the country?
Mm-hmm. Yeah, that's a great question. So it's really been in the last 10 years, I would say, that this issue has gotten a lot of public attention. And there are a couple of factors that have contributed to that. One is the ability of scientists to measure low levels of these chemicals in the environment. I would say that scientists in general didn't become aware about PFAS in the environment until the early 2000s. Researchers found that PFAS were very common in the environment, even in remote corners of the globe. So for instance, polar bears have particularly high levels of PFAS. So that set off an alarm bell that these were becoming global contaminants. I think for the general public, it's really been the discovery of PFAS in drinking water that has produced a lot of concern and testing. So I think that the UCMR testing that was conducted from 2013 to 2015, where we started to get a national picture of the extent of PFAS contamination, really opened a lot of people's eyes to these contaminants.
Great, thank you. Going to see if we have any more questions. Well, Dr. Shader, on behalf of Cheryl Osama, our Executive Director, and our Board of Directors, I really want to thank you for joining us again today to share the latest updates on your research and the regulations. This is obviously a very important topic for all of us, so we appreciate you joining us.
Well, thank you for having me, Michelle, and we're really glad to partner with MBCC on so much of the important research projects that we have underway right now.
Thank you. And to our listeners, I want to thank you all for joining us as well. And if you would like to get the recording for this webinar, it will be available later today on the MBCC website. Thank you all and have a good afternoon.